So today I'm going to talk about command line image processing with ImageMagick. And this is the topic that have been quite dear to me for many years, because I started using ImageMagick when I was working on my thesis about almost 30 years ago. And it's still going great. There are lots and lots of things that have been added to ImageMagick over the years. So if you go to documentation, for example, on ImageMagick, you will see that it's really good, but there's just so much stuff there that it's a little bit intimidating to get started because there's so much functionality. So the goal of this webinar is really to make it a little bit easier and to show you the most useful, in my opinion, the most useful commands that you might want to use in your scientific workflow. So I see people are joining, so let me paste the notes, today's notes once again into the chat. And so let's get started with ImageMagick. So ImageMagick is a tool for processing images, primarily via command line, that was created by John Christie back in 1987. I think it was released as open source or released to the wide public. Now it's open source in 1990. So it's been around for more than 30 years. And it has a huge amount of functionality, hundreds of functions. It understands over 200 image file formats. And it's available both as a command line tool. So today I'm going to focus on the command line interface, but there are also APIs, so libraries for various languages. So it's available from Python, from R, from Julia, from C++, and many other languages supported. So the latest version of ImageMagick is 7.11. And there was quite a big change one major version ago. So starting from version 6, the way the command line flags work changed. So I'll talk about it in more detail in a few minutes. And just to make sure that we are on the same page, a few things I'm not going to cover today. So I'm not going to talk about APIs at all because I think it's quite a big topic on itself. There's so much functionality in the command line we're going to cover today that we simply don't have time to cover APIs in the same webinar. There is also a popular package, GraphicsMagick, which was a fork of ImageMagick from about 10 years ago, and it's under active development. So I think there was probably some disagreement between the authors of ImageMagick, and a new project was born. But today we're going to focus on ImageMagick, the original project. So also, I'm not going to talk about using ImageMagick for animations. There is some functionality for producing animations, for example, animated GIFs in ImageMagick. But really for power work with animations, I highly recommend FFmpeg. So this is another tool which I should probably talk about in a future webinar. And I'll try to stick to some more basic workflows. So I'm not going to get into complicated topics like applying various mathematical algorithms to image processing or working with multiple layers, even though I'll talk about channels, but layers is a slightly more advanced topic. So installing ImageMagick is really easy. You can go to the webpage for ImageMagick and go to the download tab. And there are binary downloads for all major platforms, so for Linux, for Mac, for Windows. I'm on a Mac, so I use a MacBook. And on my Mac, all I need to do, I didn't even have to download anything from the webpage. I simply use the Brew package installer. And before I install ImageMagick on my MacBook, I also had to install GoScript. And the reason for this is because GoScript provides a lot of fonts that are needed for working with text inside ImageMagick. And also, on the lines classes, so classes like Cedar, Graham, Beluga, and others, we also have ImageMagick installed. It's actually part of the default environment. So when you log into the cluster, you can use the commands that I'm going to show you today. So basic usage of ImageMagick. The way you use ImageMagick, well, traditionally, at least that's what you typically see in documentation, is you would call the Magick command, and then you will add a tool to it. So currently there is a selection of 11 tools, for example, Magick Animate, Magick Convert, Magick Display, and so on. And then possibly you will have some flags, and then input image or images, and then an output image. So starting with version 6, the way the flags or the options are processed has changed. So now to simplify things, and we'll see many examples of this today, the operators will always be applied in the command line order given by the user. So it'll be clearer in when we see these examples. And also, you don't really have in practice to type magic and then the name of the tool. Usually, in most cases, you can just simply type the name of the tool, for example, convert or mogrify or display or something else. And that should do the job. So let's get started with a very simple example. And what I'm going to do is I'm going to actually use this screen. I have notes on my second display, and then I'll be copying and pasting the commands from my notes into the terminal. So I'm going to use the command convert. And what I'm going to do is I'll take an image. And as you can see, you can take a file name for an image, but you can also take a URL. So in this case, we have an online image from a website, and then I'm going to save. So it's a JPEG image, and let's just use convert to also save it into a JPEG image. So the syntax is very, very clear. Convert, then the source in case it's an online JPEG image, and then a local JPEG image file. And then I'm going to save it. So now there is a new file, forest.jpg, which is 1.5 megabytes. So convert actually downloaded the original JPEG without any, obviously in this case, without any conversion because I didn't specify any flags. So one of the commands in ImageMagick is identify, and it's useful to show basic information about an image. So here we're going to say identify forest JPEG, and it gives me some basic information like the file name, format, the resolution, bit depth, so it's an 8-bit image, the color space as RGB, the file size, and some other stuff. So you can also ask it to provide more information by supplying the verbose flag to identify. So identify -verbose forest, and that will give you a huge amount of information. So it'll be several pages long, and most of this you probably don't need. And also, you can supply exactly what you want to have printed as an output of the identify command. So I like to use it the following way. So here I'm going to say identify format, and then in this string, I'm going to output the following information. So I'm going to have the file name, the width and the height of the image, number of channels, along with the color space, the bit depth, and also the compression ratio. And then you need to actually see this output, you need the end of line at the very end of this string. And then here's the information that I asked for. So you can see that it's a 3000 by 2000 roughly image. It has 92% compression, JPEG compression, and so on. So you might also, if today we're going to be querying images quite a lot for size. So you might find the following alias to be quite useful. So it will output the file name, and then the width and the height of an image, right? So I'm going to say size, and then let's say forest, and it simply returns that basic information. So now let's actually try to convert an image to different formats. So I'm going to say convert, and then I'm going to say forest JPEG, and let's convert it into a PNG format. You don't have to supply any flags. Convert will simply deduce the target image format from the extension, right? So here we're converting to a PNG file, and then if I look at the sizes of these files, you see that we have a 1.5 megabyte JPEG image. So JPEG has lossy compression, and then PNG in this case it's less useful for photographs. In this case, it's a photograph of a forest, and that's why the image size is so much bigger. So to display the image, there is a built-in command display. So normally in ImageMagick, you will say display and then the file name. So let's say the JPEG file. On my MacBook, it actually doesn't work. And the reason why it doesn't work on my MacBook, so here it just shows various options. So this is the command I try to run, is because I installed ImageMagick via Homebrew. So I download essentially a precompiled version, and this precompiled version does not support X11. So ImageMagick displays images using X Windows system, so Unix-based windowing system, and it doesn't work. So it has been compiled. Support for X11 has been compiled into this copy of ImageMagick on my machine. But actually, towards the end of this webinar, I'm going to show you. I'm going to demo ImageMagick running display command on the CD cluster. So there it will actually work remotely, and you will be able to see the image. So in my case, what I'm going to do is I'm going to use the use the open command, which is something that is specific to macOS. So in this case, I'm just going to open an image, and here it shows this forest image, right? But if you're on Linux or if you're on Windows, this is equivalent to, I guess, running, well, double-clicking on the file forest JPEG inside your file manager. So to see the list of supported formats, you would type convert -list and then format, and that will give you a long list. So I counted 211, I think, if I'm not mistaken, quite a lot of stuff there. So you can actually grab, for an image format, let's say JPEG. Does it support JPEG? Well, obviously it does. PNG has support for PNG. Actually, quite a lot of codecs for reading and writing PNG images there. It also supports more modern file formats like AV1, so AVIF, which actually I'll be using a lot today for demos. So AVIF is kind of an equivalent, modern day equivalent of JPEG. So it works really, really great for photographs. And the big advantage of AVIF is just much more efficient than JPEG for compressing files. So typically, if you have the same quality image in JPEG and AVIF file, the AVIF file will be roughly 2 or 3 times smaller. So that's why it's an open source format. So it's an open source format released about 5 years ago by the Alliance for Open Media, and it supports both lossy and lossless compression. So let's try to convert it into an AVIF file. So all I need to do is just say convert, then forest JPEG, the original file, into an AVIF file. And if I look at the file sizes, you see that we went from 1.5 megabytes to roughly half a megabyte. And if you display 2 images side by side, you actually pretty much won't see any artifacts of compression. So it's going to be very, very, very similar to the original image. All right. So another format, modern day format that I want to mention is Google's WebP file format. So it's also open source, also supports lossless and lossy compression. But it was created by Google, so it's not in, there's no big alliance, big open source alliance behind it. But if you look at the file sizes, you will see that it produces slightly larger files, so comparable to JPEG files. So let's actually see where this convert utility is sitting. So far I've been using convert. Also, I ran identify a couple of times. So convert is sitting at this location, right? But this is actually, in my case, it's a symbolic link, which points to an ImageMagick directory inside the Homebrew installation. And if I want to actually list other utilities, I'm going to say which convert, right? And then I'm going to pipe it into a real path. So this will unwrap the symbolic link. So it will actually, instead of showing the symbolic link, it will actually show the file that is pointed to by this link. And then I'll pipe it into, I'll extract the name of the directory. So I strip the file name, and then I'll show everything inside that directory. And so here you see the 11 tools that I mentioned before, right? So there is convert, there's identify, mogrify, and there are a few others. So we won't look at all of this today. We'll probably look at half of them. Some of them I will simply don't have time to talk about. But yeah, if you want to learn, for example, about stream, I'm not going to talk about it today, then you can go to the documentation. So let's convert also a couple of other images. So I'm going to take an image from Wikipedia, from Wikimedia. So it's an open source image, and it's a image of hills. So here I'll just using convert to take a JPEG file and convert it and save it directly into an AVIF file locally. So it's a file like this one. Also, let's take a couple other 2 images. So an image of an ocean and an image of a desert. And all of these cases, I'm saving them as AVIF files. So if I use my size alias, just to remind you, this is the alias to identify to show the file name and the size. If I'm say, show me the sizes and the file names of all AVIF files, well, this is the command I'm going to use. So these are all fairly high resolution images, right? 3,000, 4,000 pixels on a side. So the command convert, there is actually a manual page you can access. If you type man convert, it will actually show you about a couple of hundred different flags, quite a lot of functionality there. And the interesting thing, of course, there is also online functionality, but the interesting thing is that there's also a reference. So in this installation of ImageMagick, there is also a online, well, not online, sorry, offline HTML file that is sitting locally on my computer. So if I click on this guy, it will just open this file. And there is also all online documentation that you can find on ImageMagick is also accessible via this offline file, right? So you can go, follow the links, and pretty much everything you can find online about ImageMagick and the facial documentation is also available as offline documentation installed locally alongside ImageMagick on your computer, which is really great because that means that you can actually access documentation even if you're offline. All right. By the way, if you have any questions, feel free to type into chat or unmute yourself at any point. So questions are more than welcome. So let's actually start doing applying some flags with convert. So the first thing we're going to look is resizing files. So I'm going to say convert, and then I'm going to take the forest AVIF file. So that's the 3000 by 3000 or so image, very large image, and then I'm going to reduce it by 50% in both dimensions. And then I'm going to save the file as F1 AVIF. So it takes about a second or so to do it. So now if I run size on the original file forest and then F1, you'll see that this guy is roughly half the size of the original file. So if we inquire about the file sizes, it should also be about a quarter or a third of the original file size. And then if I display it, well, it will show the original forest. So resize percentage is very simple to use because you don't have to inquire about the size of the original image. You'll just reduce it by by a factor of 2. So if you prefer to work with pixels, you can also supply a number of pixels to the resize command. So for example, you can say resize to size 1600 by 1600. So I see a question, I'll answer in a second. So there is the original image of forest AVIF is 3400 by 2300, right? And here we're saying resize to 1600 by 1600. So this command will actually keep the aspect ratio, right? So what it will do if we inquire about the size of the result, F1, you will see that one of the dimensions is going to be 1600, and then the other dimension is going to be smaller, right? So it keeps the original aspect ratio, which is great, but then it applies 1600 to the largest side, and then the second side is going to be smaller than that. There's a question: does ImageMagick also have a GUI that we can view the immediate steps, or is it only command line based? No, it has the GUI. So if you run the display command, so display command requires X11 server, right? But in my case, as I mentioned earlier, the display command was not compiled into into the version of ImageMagick I'm running on my MacBook. But if you download it for, I'm sure, I guess if you compile it from source, then it will come with a display command, or maybe another build of ImageMagick will employ the display command. So in my case, it just doesn't work because the display command was not compiled in it. But the answer is display, and if it works for you, so if it was compiled into your distribution of ImageMagick, then it will show the image, and then you can click on the image. It will display a menu, and there is a lot of functionality there. So you will go to convert, or you can apply a blur, or you can resize an image. Lots and lots of functionality there. But today I'm going to talk about primarily using ImageMagick on the command line, and the reason for this is because you can use it via command line on our clusters as well. All right. So the command will run to resize to an image of size 1600 on one of the sides was this one, right? So this command keeps the aspect ratio. If you want to apply this size 1600 to both a height and width, and you want to enforce it, so now it won't keep the aspect ratio. The way to do this to enforce this size in ImageMagick is to use the following syntax. So / followed by the question mark will actually enforce the size. And now if I inquire about the size, you can see that it's 1600 in each dimension. But of course, now we have a modified aspect ratio. So the picture has been modified, as you can see. So now it's not as wide as it used to be. You can also supply one of the sizes. So you can supply either horizontal or vertical size. So in this case, it's going to resize to 1600 on the horizontal side. So this is going to be the width, right? So now we have a width of 1600. If you want to specify the height of 1600, this is the way you do it. So this is the height, and now the image is 2400 by 1600. So in both cases, this case and this case, it keeps the original aspect ratio. So you can also supply other flags. So here's an example of another flag. So let's also add a flag to convert the image to grayscale using a specific, dash grayscale, using a specific grayscale map. So in this case, we both resize the image to the size 1600 on one side, and then we also converted it to grayscale by passing these two flags. So if I open the image now, you see that it's a smaller image, and it's also black and white. All right. So are there any questions about resizing? So resizing is really, really trivial, as you can see. Next, we're going to talk about cropping and working with images. By the way, if you have any questions that you put into chat, please make sure to write them to everybody, because I don't always have time to read chat, but we have my colleague in the room who will be able to answer other chat questions if you have them, but please address them to everybody. There's another question. If you have a low complexity PNG logo, perhaps, is it possible to convert to SVG format? Yeah, absolutely. From SVG to PNG, JPEG, or TIFF. Yes, so I'm going to show you an example of converting from an SVG to PNG. So the problem, and that is easy. So to go from a vector format to a bitmap format, so let's say SVG to PNG, is very easy. ImageMagick will do it. So I'll show you a demo. To go in the opposite direction, from a from a bitmap, let's say from a PNG image to a vector SVG image, this is a little bit more difficult. So ImageMagick can do it. But I don't remember how I did it, but you have to add some extra flags. So basically, the challenge there going from a bitmap to a vector image is that you don't want to keep all the information from the original image, right? So for example, if you have, I don't know, an image with just a line, you just want to specify, the background color and the line, but nothing else, right? So I'm not going to talk about it, but it's possible, yes. So if you're interested in how to do this exactly, send me an email and I'll be happy to show you how I did it. I just don't remember right now. So let's talk about cropping. So let's take our image of a forest, and then so the large image with file, and then let's do a dash crop flag, and let's pass the following values. So 500 by 500 at a 500 by 500 crop. So my output is going to be 500 squared image, and then I'm going to crop at a specific offset, right? So this is the offset in the original image. So now if I show you the size of the output image is going to be 500 squared image. And now if you show the size, well, the original image and then the cropped image, you will see that the cropped image is really, something that is somewhere in this part of the original image, right? So we cropped a specified 500 squared image at a given offset. So if you want to crop, you must always specify an offset. So you don't have to specify the size, but the offset is necessary. So here's an example without the size. So here I have just the offset. So the offset starts with plus 800 plus 1050. So in this case, we are starting from this location in the original image, right, with an offset, and then we're cropping all the way to the lower right corner. So we're starting with an offset and we're cropping all the way from this offset to the lower right corner. So now if I display the two images, now you see that the image that we get is roughly starts somewhere here at the offset and then goes all the way to the lower right corner. You can also have a zero offset, and that allows you to crop starting from the upper left corner, right? So here's an example of doing just that. So here I specify the size and then a zero offset, and that will crop from the upper left corner to a specific location, right? So that will become the size of a new image. And now if I display the two images, you see that the cropped image starts from the upper left corner and goes all the way to the specified offset. Is ImageMagick freely available for Windows? Yes. So go to ImageMagick page, go to downloads, and you can download a binary version for Windows. The answer is yes. And you can use it via command line from, well, I guess via DOS command line. But yes, all commands I show you today, they also work in Windows. All right. So far we use crop with an offset, right? So everywhere we had an offset. What happens if you run crop without an offset? Well, it turns out that instead of cropping, Convert will actually segment the original image. So let me show you an example. Let's do crop and specify percentages. So we're going to say crop 30% by 100%. So what will happen is crop will actually split this into 4 pieces. So we're taking the entire height of the image, right? And then we're specifying a 30% width of the original image. So that means they'll actually break it into 4 pieces. So the entire image will be chopped into 4 pieces, 30%, 30%, 30%, and 10%. Width-wise, right? Horizontal is going to be a horizontal split. So when I do this, we're starting with an original image, and then we're specifying the name of the output file. But actually, it turns out that there are 4 output files, and the reason for this is because we have now segmentation of the original image, right? So there are 4 pieces, and you can see the last piece is the smallest. So if we specify a smaller number for the vertical split, then it's going to split, let's say if we do something like this, right? Then it's going to segment it both horizontally and vertically. So in this case, we'll have four segments in the horizontal direction times 5 segments in the vertical direction, right? So it should result in 20 images. So let's see. So now we should have, yeah, exactly. We have 20 output images. So you can also supply a single percent number, and that will use that single percent number in both dimensions, right? So if I do this, that should result, actually, let me remove all those pieces, PNG files, and then, let me run, let me run the following command where I specify percentage, just a single number, and that single number will actually apply to segmentation in both dimensions, right? So it'll give me 4 pieces vertically, 4 pieces horizontally, so I should have 16 images in total. So now if I do this, there are 16 images. So to show you what they look like, here we go, right? So we're splitting both in horizontal and vertical dimensions. You can also supply the size, the absolute size of your segments. So for example, if you do something like this, minus crop 512 by 512 is going to convert into the original image into 35 images, right? But this time, unlike in the previous command, so in the previous commands, I use PNG for the target output image. This time, I use the EVIF format. And now if I look at pieces.evif, you see there is just one file, but it turns out that EVIF actually supports multi-page images. So if I open it, you see that now there are 35 segments, but they're all part of the same file. So there are many pages inside the same image file. All right. Since we started talking about portions of an image, about regions, we can also apply operations to a portion of an image. So let's take an image. Let's take our original forest image, and then apply a negate flag to it. So negative, negative operation. So we are computing the negative of an image. So if I do it like this, it will simply take the original image, and then it will produce a negative image, negative color image inside f1.evif file. The size is going to be exactly the same as the original, right? Because we're not cropping, we're not resizing, we're just keeping the original size, but it's going to be the negative image, right? So we have the negative image, and we obtain it by applying the negate flag to the entire image. But it turns out that you can apply the same negate flag to a region. So the way you do this, first you actually have to specify the location of your image, and you can do it in many different ways. One of the faster ways of doing this is to use the gravity flag. So it will simply let you choose, one of the corners or the center of the image or the top of the image. So let's actually choose the center of the image. And then in the center of the image, we're going to select a region of size 300 by 300. And then we're going to negate that region only, right? So in the middle of the image, of the forest image, we are selecting the region 300 by 300, and then we are negating only that region. So the negate operator will apply only to the central region. So to verify that we still have the original size, we can run size, right? So the size has not changed. And now if I show you what the image looks like, you'll see that negative, negation, negative operator was applied only to the 300 by 300 region in the middle. So let's try to apply another operator. Let's try to apply a blur operator. So blur operator will obviously blur an image, and it requires two arguments, two numbers. The first one is the radius of the blur, and it's in the number of pixels. If you supply 0, that will blur an image, but it will actually use a very, well, it's not a stencil. It's it will apply the blur operation to just a single pixel. But you can also supply, you must also supply a sigma or the width of your stencil. And that's also in the number of pixels. And let's just select, a blurring operation to be 10 pixels wide, but then the result is going to be applied to a single pixel at a time, right? So when I do this, again, I'm applying this operation, this blurring operation, only to the 300 by 300 region in the center of the original image. So if I look at it, you see that now this 300 by 300 image was blurred, by using these specific numbers. So once again, the numbers are the width, the number of pixels that you are modifying at a time. So 0 means that you're modifying 0 and 1, I guess, will produce exactly the same result. So 0 means that you're applying just modifying just a single pixel at a time, but you are modifying it with using information from 10 neighboring pixels. So that's your sigma. Let's now apply the same blurring operation, but instead of specifying the gravity, right, keyword, let's actually specify location with the region keyword. So here we're selecting region 300 by 300, but then we're going to add an offset. So let's put it in the center of in the middle of the image horizontally. But then let's put it near the top. So let's do something like this, right? So now in the top of the image, top middle of the image, we're gonna have a blurred image of size. Let's do size 500 by 500. So we're applying our moderate blur operation to the specific image, right? And here you see that now we get the result of this blurring operation right in this square. Right. So question, how do we blur an entire image? Anybody can tell me? How would I blur an entire image? Feel free to paste the command if you want into the chat, because here we apply the blur operation just to a single image. Sorry, to a region, not to an entire image. So how to apply it to an entire image? Well, the answer is very simple, right? So you just don't specify the region. You just run this command without specifying the region, and it'll just blur the entire image. So I remove the region flag, and now it simply blurs the entire image, as you would expect. All right, let's talk about whole image transforms. So there are various commands for modifying the entire image. There is the flip command, which will flip your image vertically. Flop will will flip it horizontally. You can also rotate by a given angle. So for example, rotate 90 degrees will rotate clockwise or counterclockwise by 90 degrees. It turns out they actually don't have to specify 90 or 180 or 270 degrees. It could be any number. And then if you're rotating by an oblique angle, it will introduce borders. So let's actually do that. Let's rotate my entire image, let's say by 30 degrees. And then this is what it looks like. So now, as you can see, we get a larger output image where we have the original image. So I assume, let's just inquire about the file size. Yeah, so now the file is even bigger than the original image because we now have white borders around it. There are also various commands for transposing, transpose, transfers. So they combine flips and rotation. If you want to add a border, you simply see minus border, and then you pass the border width in pixels. So let's just do that. Let's say we're gonna apply a border to the original image of with 10 pixels. And now let's actually specify the color of the border. So border color yellow. And now, as you can see, now we'll have a yellow color, like yellowish. Can't really see that it's yellow on my screen, but it should be, yeah, it should be yellow color around the original image. I'll quickly show you how to make the background transparent. So let me actually go back to this web page, and let me take a screenshot. So I'm gonna, I'm gonna take a screenshot of this website. So it has, the website has a lot of, well, it has a lot of white in the background, right? So let me actually move the screenshot. I'm gonna say screen.png in the current directory. So here is what my screenshot looks like, right? So a lot of white in the background. And let me actually show you how you can make it transparent. So I'm gonna say convert, then the original screenshot image, then I'm gonna say dash transparent, white. So what we're doing here is we're taking all white pixels and we're making them transparent. So all white pixels in the original image, and then let's write it into a PNG file as one.png. Oops, transparent white. Let's see what's wrong. Not permitted on grayscale PNG. Not sure. So let me see if it worked. No, it didn't work. So why it didn't work? Well, maybe we don't have the perfect white in the background. Actually, let me run another tool that will tell me exactly. Yeah, so we don't have, so the reason why it wasn't converted is because we don't have exact white. We have, this color FC, FC, FC. So let's actually, let's actually specify that we want to convert all pixels that have this color in hexadecimal notation. We're going to make them, all these pixels, transparent. So let's see if that worked or not. And that worked. So it issued some warning. So it's complaining about the color space, but the important thing that it actually works. So now we see that all these pixels were made transparent. So now, if you are not sure about the exact color of the pixels that you want to make transparent, or perhaps maybe there is some variation in the background and you just want to make all these pixels transparent, there is a fantastic flag which is called fuzz. And what lets you do, you specify the percentage. So actually, let me see if this works. If I go back to making the running the original command where I try to make all white pixels, and my background I know is not quite white, it's almost white, but not exactly, it's a little bit grayish. And I'll try to make all these pixels by saying that in the command that I want to make the white pixels transparent. But then what this fuzz means, it means also convert all the pixels which differ in total luminance from your target color, from your source color by no more than 3%, right? So it looks at luminance, and let's see if it actually works. If it doesn't, then I will need to widen that percentage number. So it didn't work. So let me try 10% and see if it works. So because all this is actually a grayish color right here, right? So it's not exactly white background, and I'm specifying white as the color that we're making transparent. So let's do 10%. Let's see if it worked. No, it didn't work. So let's do 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. 30%. And nope, 30%, that didn't work. Okay, well, maybe 80%. No, they're too different. Okay, then yeah, then then I'll have, so very often it works, but in this case actually didn't work. So not sure why exactly this didn't work. Well, anyway, so yeah, maybe you want to supply a color that is closer to the actual color in the image, and then this command will actually make all white pixels, or all pixels of this exact color transparent in your output image. So we're going to talk about transparency a lot more very soon. I want to go to the next section, which is in place and batch processing. So similar to the convert command, there's also a mogrify command, which takes exactly the same arguments as the convert command, but mogrify places the output into the source image. So basically, it modifies the original image in place. So for example, if I say mogrify resize 80% on the file ocean.aviv, and actually, before I do this, let me show you the size of the ocean file. So ocean file is this size, 3700 by 2500, and then I'm going to run the mogrify command. So just resize the original image and then write the result back into the same file. So now resizing by 80% will result in slightly smaller file size. So all the flags that I mentioned before, so crop, region, blue, etc., they also work with the mogrify command. So the only difference between convert and mogrify is that that convert requires at least 2 images. Mogrify requires 1 image because it'll override the original image. So let's write a slightly more complex command. So we're going to issue the following flags. So we're going to take all EVIF images in the current directory, and then we're going to convert them to PNG images. We're going to resize to 1,000 pixels on the horizontal side. And then we're also going to convert to 8-bit color if they're not 8-bit color, if all these EVIFs are not 8-bit color. So, but basically here you see I'm doing batch conversion of all EVIF images to PNG images in the current directories according to these specifications. So now if I do this, it will take a few seconds because there are quite a few EVIF images, but now you will see that it'll convert all these images into PNG files because I saying format PNG, so all output is going to be written to PNG files. And so here you have quite a few PNG files, but these are various image files that should have, actually let's verify, they should have they should be 1,000 pixels on the horizontal side. So I mentioned, there was a question earlier about SVG files. So SVG is a vector, so not bitmap, but a vector format. And here I have a file. Let me copy it into the current directory. So this file is an SVG file. And actually on my computer, the way I view SVG files is by using Emacs. So here, if I open Emacs, this is what this file looks like. So it's vector graphics, right? And then the file is tiny because it's vector graphics. But then with convert, I can easily convert it to a PNG format. So let's say if I use mogrify and I want to change the format, I will have to say -format PNG. So I run the following command, converting this vector file to a PNG file, and I will fill in a background. So I assign this color to the background. And now if I do hybrid parallelism PNG, it should show me the new image with this gray background. So now if I want to make the background transparent, all I need to do is issue so here I have the new PNG image with a background of this grayish color. And then I'm simply making all these pixels transparent with mogrify. So I'll update this file in place. And now if I display this image, you will see that now I have a transparent background. So another command to make it transparent would be to remove background by saying background none. And the output result is going to be visually the same as before. So it's going to be transparent. But there's actually a difference between running this command and running this command in that the -background none command will actually completely remove the background, whereas by using transparent flag, you are hiding the background, but it's still present in the original image. So you're adding an alpha or opacity channel. We'll talk about this in a few minutes. Whereas you're hiding the background, but it's still present in the output image in this case, right? So if you look, for example, at the file sizes of this guy, and then this guy, there will be, of this guy, after this separation, and then the same file after this separation, you will see that they will be different quite a lot, because one of them will have the background, the other one will not. So let's talk about joining images. There are many, many different ways you can join images. So let's take the following two images. Let's take desert EVF image and then forest EVF image. This is what they look like, right? So two pictures. And then let's inquire about their sizes. So they're both quite big. Let's actually reduce their sizes. So let's run the following command. Montage will merge or will join multiple images. So in this case, we're taking two images, desert and forest, and we're joining it into an image mosaic 1. And in this case, we are supplying the horizontal size. So we're just saying that take these two images. So these geometry flag will apply to both source images. So both of them will become 1200 on the vertical side, right? And then you are merging them into a single mosaic. So let's see what it looks like. And unfortunately, as you can see, it worked, right? But the result is not very nice because you have also these borders. And I haven't figured out how to actually get rid of these borders with montage. And for this reason, well, perhaps I'm pretty much sure it's possible, but I actually prefer to join images by using the convert command. And actually, the results will be much nicer. So I'm going to say convert. Also, geometry x 1200. So that's going to be the vertical size of these two images. So desert and forest, and then I'm going to merge them horizontally. So by using the plus append command, and then I'm going to say mosaic 2. And when I do this, you will see that both source images will be resized to 1200 on the vertical side, and then they're going to be merged horizontally. So now if we look at the mosaic 2, you will see that we have a nice merge, and we don't have any border between the two images. So if your goal is to have a border between the two images, this is super easy to do. So all you need to do is when you process the images, so after you resize them, you also add the border to the original images. So let's say a border of 30 pixels wide on all sides. So what this means is take these two images, then apply these processing to the two images, so resize them to 1200 in vertical direction, apply a border 30 pixels wide, and then merge these two images horizontally, right? So when I do this, again, you will see mosaic 2. Now you have a border around each image. So how do we get rid of the outer border, but keep the border, keep the white space in between the images? So one way to do this would be to use the trim command. So I'm going to say take the output mosaic, so mogrify output mosaic, and then use the dash trim command. But it turns out that it actually doesn't work very nicely. So you see that it kind of trimmed a little bit. So it relies on auto detection of borders. Actually, what it does exactly, it looks for the very first pixel in the upper left corner of the image, and then it trims using the border of the same color. And in this case, it's just for some reason, it just figured out that these borders right here, the bottom, for example, have a different color. So for some reason, it didn't work here. But it turns out that I can actually make it work, make the trim command work if you use it in the original merging operation. So here, all you need to do is simply say trim, and then it will introduce a nice border, a nice white space between the images, and then it will trim them properly. So here processing happens. This is very important. Here processing happens from left to right, right? So quite a lot of stuff that we're doing here. We're taking the two original images. We are resizing them. We're applying the border all around these two images. We are appending them together horizontally, and then we're applying the trim to the outer border of the image. So if you want to join them vertically, all you need to do is change plus append to minus append, and this will join them vertically, but also you have to modify these resizing operation, right? Because now if I join them vertically, you want to make sure that it's not their heights, but their width that are exactly the same. So let's just do this. Let's have them their width equal, right? To set them to 1200 for both desert and forest, and then to merge them, to join them vertically, you apply, you use the dash append flag. And then let's write it to Mosaic 3. So now if I show you Mosaic 3, this is what we get exactly. And now the width of this white region between the images is 30 plus 30, so it's 60 pixels wide. I find that so I do merging of images all the time, but I never remember, the exact syntax of this command. So the way I do this, I actually define these two functions. So merge images vertically and merge images horizontally in my .bashac file. And this is very useful because I don't remember syntax in general. So what I do is, let's say I want to merge images vertically. Well, I just run this command without any flags, without any arguments, and it tells me exactly how to use it, right? So here you need the output image. Let's say I'm going to call it 111.png, and then I'm going to say, then also need the shed size, right? So I'm merging images vertically. Let's say 800 is going to be the shed width. And then here I'm going to say ocean, AVIF, forest, AVIF, and let's do a third one. Let's say desert AVIF. And now we'll have all three images joined without borders, without actually any separation, vertically. So we resize them and we join them together vertically. Okay. So if you want to do two-dimensional merging, I see that we don't have a lot of time. There are many, many different ways of doing that. So you can do that using montage. I personally prefer to use a two-step operation where you join images first in one dimension and then you join images in the other dimension. So let's say we can do these two mosaics, Mosaic 1 and Mosaic 2, right? So in this case, we are setting in each mosaic, we are setting the same height for both, actually the same, we're doing vertical, these are two vertical merges. So one of them, let's just display one of these images. So yeah, they're going to be vertical merges. So this is the width of each mosaic, and then you can actually merge them horizontally. So here is the horizontal merge, and then the output is going to be this very nice mosaic where I really prefer these to what you get when you use a combination of montage command. And the reason for this is because this approach will keep all original aspect ratio and does not waste any space. Whereas the montage commands, if you play with this, you will see that will be quite a lot of white space in the output image. So you can also add images to a new canvas. And the way you do this is first you create a new canvas. Well, actually, you don't even have to do that. You can actually do it directly. So let me show this command. So here we take the desert image, and then we resize it by 10%. So we make it much smaller. And then we place it in the center of a new image, so gravity center. We're going to give it a white background. And then the output image is going to be of size 520 by 300. And I'm going to call it overlap.aviv. So if I display it, you will see what happens. Here we take the original large image, we resize it by, we reduce it by a factor of 10 in both dimensions. And then we place it in the center of a new image with a white background of this size. So you can also achieve exactly the same result if you take the original image, resize it by 10%, and just apply a border of this size, right? The output is going to be exactly the same as in the previous command. So now let's add another image. So now what we're going to do is we're going to take our new overlap, our new image of the desert, and then we're going to add superimpose an image of a forest, and we're going to resize forest also to a size of 100 by 100. So remember, if I specify size like this, it's one of the dimensions that is going to be exactly 100 pixels, the larger one, and the smaller one is going to be smaller than 100 pixels. Is going to keep the aspect ratio, and then we're going to place it northeast, means in the upper in the upper right corner, and then we're going to overlay it on top of the original image, and then the output is going to be written into overlap.edif. So when I do this, you'll see that now we have the image of a forest of size 100, 100 wide and a little bit smaller on the vertical side is going to be placed into the previous overlap image. And so these two brackets are actually very important because this means that this resize operation only applies to the forest image, right? So if I remove these, the result actually will be very different because the resize will be applied without these brackets to both overlap and forest image, right? So the result will going to be a very small forest image, right? Because what happens here without brackets is that you resize both of these guys, and then you put these on top of the smaller overlap image, right? So now the end result, you don't see the overlap image. So that's why it's really, really important to have brackets here to only apply the resizing operation to the forest image. So alternatively, you can actually start by with an empty canvas. So here I start with an empty canvas. So here my canvas is empty, right? I'm creating a new image, size 520 by 300, and filling it with sky blue color. And then I add images one by one. Actually, because I'm running out of time, I'll just run all these commands so you can study the difference between them. They're actually quite different, so different ways I specify the geometry. But here's the result. I add 4 images to these canvas. So drawing here, I was not planning to talk about any complex commands, just to show you a few examples. Obviously with ImageMagick, you can draw various shapes. So let me actually show a slightly more complex command where we draw 3 triangles. So in this command, I initialize a new canvas, so with the light blue color, size 500 by 300, and then I draw 3 triangles on this. So what these lines are: M means I start a path. So here's a path. I draw a path, right? And in each path, I start the path with this point. Then I add this point. Then I add this point. Z means close the path. So here I form a triangle, second triangle, and a third triangle. So I actually do this and then show you what it looks like. So there's going to be three triangles, but they're also going to be filled with a white color. So here I fill it with a white color. Stroke black means that I also have a black border around these images. And then for the fill rule, I have Evernote. So there are actually 2 fill rules supported by ImageMagick. If I run the command magic, or I guess convert will probably will work. I'm not sure. Convert, yeah, works as well. So list fill rule, there are 2 rules, even, odd, and non-zero. So what it means, even odd means that if a certain section is part of an odd number of triangles, then the fill color is going to come from the background. If it's if that pixel is part of an even, actually other way around, yeah, even number of triangles, we use the background color. If it's an odd number of triangles, we use the fill color, right? So there are 2 colors here, sky blue and white, and here's what we get. So if I replace these to the second option, so instead of Evernote, if I have the second option non-zero, we'll actually produce a result which I think is wrong, and I think this is a bug, unless I misunderstand something. So here's the result I get, and I think this is a bug in ImageMagick, because in my opinion, what non-zero should do is it should place basically everything that is part of a triangle should be white, and then everything that is background should be light blue. In this case, you see that there have some missing pieces, but I think, in my opinion, it's a bug in this non-zero algorithm. Anyway, so I'll skip to the texts. In my case, I install GoScript before installing ImageMagick. So I'll finish in a couple of minutes. Just want to show you a couple of other things. And so here, if I list all the fonts, it turns out that ImageMagick has access to more than 2,000 fonts on my computer. So here's just to show you how we can utilize this. So in this case, I generate an image hello of a given size. So this is going to be the size of the image. This is going to be the color of the background. This is going to be the font size. This is going to be the font I'm using. I'm also filling the letters with white color. and then I'm using a background of, sorry, not background, the stroke, so the border of each letter is going to be drawn in black color. The width of the line of the border is going to be 2 images, and then at this position inside the image, I'm gonna print hello with the exclamation mark. So here's the result, right? You can also cycle through all fonts. So here's an example where I go, oops, sorry, let me actually show you the command. So here's the command, and I go through a bunch of fonts. I create a bunch of images, and then I convert them to a single image called some fonts. So if that works, that should actually display a bunch of fonts. But as I said, I have access to more than 2,000 fonts on my system. So here I just decided to show these specific fonts. So I'll skip. So here's how you add and text to an existing image, and super easy to do. So again, you can specify the font size, the fill color for the letters, the font itself. You specify the geometry, for example, location in this way. We can do it through gravity, right? And then so here's my forest image, right? The one thing is that you have to be very precise about the placing, so make sure that it's actually within the image. So let me do this. So I'm adding forest road text to the original image, and here is what it looks like. So here you have forest road in this fancy font. All right, so we're out of time, unfortunately. And one thing that I want to talk about is working with channels. And this is really interesting because it gives you access to actually individual channels that are part of an image. So typically each PNG image has 4 channels, red, green, and blue. And then you also have the opacity. But I think I'll just show you one example, and then I will stop. And then you can run these on your own after the workshop. So one example that I wanted to show you. So here I generate very quickly some text. So I generate some text very quickly. Hello. Then I add some hidden text, smaller text in a different color, right? And then what I do is I make the background transparent, but I also do this. So here's the background color, which is this, this gray bluish color. But if I supply the fast keyword and say 10%, it will actually make not only my background transparent, but also make the text, the hidden text transparent as well. So let me show the result. So as you can see here, it's not only the background that becomes transparent, but it also this text. So this text will be hidden. That is transparent as well. But it turns out that this text is actually not transparent. You can actually bring it back by using many different ways. So one way would be to take this image and convert it into a format that does not support transparency, right? So here I take my transparent image, transparent PNG image, this guy, and convert it into a format, into JPEG that doesn't support transparency. And as you can see, now it just strips off, it converts it to JPEG file, it strips off the transparency layer, and my image, my text is still there. So whenever you use -transparent flag to make something transparent, make sure that please keep in mind that the original image is still intact. There is just the what you do with -transparent flag is you add a transparency layer that modifies your image in some way, and then you can actually in this case I can add a tile background. So here's a checkerboard background. It's a pattern that is built into ImageMagick. It's not a file. It's just something that is built into ImageMagick commands. And here I simply overlay my transparent image over a checked background. And just to show you what it looks like, so hello checked is going to be an image that looks like this. And then in the rest of this example, I can modify my transparency layer. I can negate my transparency layer. I can extract different colors. Actually, let me show you very quickly how we can extract different colors. So here I take the alpha channel and I extract the transparency layer itself. So let me show you what it looks like. So here is the transparency layer itself, right? I can also extract different channels, red, green, and blue. And actually, the way to do this, the best way to show this would be to take a photograph, like a picture of an ocean, and then extract, let me actually extract of a forest. Actually, let me do this. Let me this is the very last example I show. So I take the forest picture, so forest picture, AVIF, and then I will extract the red channel from it. So I'm going to say red.avif. And then I'm going to show you both the forest image and then just the red channel. So here's the original image, and here's just the red channel. So unfortunately, I'm out of time, and there are a few other demos I wanted to show, but I think I covered most of this stuff. So feel free to play with these examples on your own. So as I mentioned, we have ImageMagick installed on all our clusters. So if you're looking, for example, to Cedar, if you have an image there, you can play with various commands, including the display command that doesn't work on my computer, but it will work on Cedar. If you have X11 server installed on your computer, then we'll simply display this image on your laptop's screen. I think I will stop here, and if there are any questions, feel free to type in the chat or just unmute yourself.